Am I audible? Hello? Hello? Am I audible?
Yes, ma'am.
Good evening, all. So, if you can remember, in the last class, we were discussing, and we have started the discussion on multicollinearity, and I told you that I am going to finish up that portion today. So, I am starting with that portion only today. Okay?
Okay.
Just give me 1 minute. Let me share. Hope the screen is visible. Okay, if you can recall, this was my actual question that what is multicollinearity and discuss the effect of multicollinearity using a three-variate linear regression model. So I am not going into the details of multicollinearity today, but explaining whatever we are asked to do over here only. Okay. So if we say what is the multicollinearity, basically there are two consequences of multicollinearity. One is my exact multicollinearity and one is my near exact multicollinearity. Okay, so what is my exact multicollinearity? If we have in a multiple regression equation the correlation between the two regressors x2 and x3, we know that suppose we have equation like this, since we are discussing in a context of three-variate regression. Suppose this is my equation. So suppose I say that in this multiple linear regression, the correlation between two regressor, it can be any two regressor. I am over here considering two regressor. It should be any two. Suppose example x2 and x3 is absolutely 1. Is absolutely 1. That is, I am actually finding out this thing. In the correlation matrix, I wanted to see this thing. That is, the diagonals will be 1 or one of the diagonal element corresponding to the 2 3 will be 1. Then the corresponding model, what is my model over here? My model over here is basically star, suffers from multicollinearity. So this is the concept like where the correlation will be exactly equals to 1. It is not only related, it is the correlation among the between the two regressor or the two covariates will be exactly actually equals to 1. But in case of near exact multicollinearity, we have the scenario is different. Here in a multiple linear regression model, if the correlation between the same thing, the correlation between any two regressor. I am taking over here the same example, x2 and x3, is not absolutely 1, but it is close to 1, then we say that the problem is near exact multicollinearity. So we are now going to discuss, and if we say multicollinearity, we actually mean that exact multicollinearity. And under this exact multicollinearity, let me consider the model again. For the ith value, the model will be exactly like this. Okay, there are three variants you can see, and suppose I am assuming, without loss of generality for explanation, I am assuming that x2i is equals to lambda into x1i. That is, these two variables are basically related. With respect to that, what you need to find, you have to find the beta 1 hat, obviously ordinary least square estimate, the value of that. You need to find beta 2 hat. I am not finding, I know that you can find this out, so I am just, due to the short of time, I'm just discussing this thing at what you need to find. Okay, beta 3 hat. So for these estimates, you need to find this thing. Okay, and next, if you can see that since these two covariates x2 and x1 is related, you will be seeing this, that this beta i's, not all the beta i's, this beta y1 dot 2, the relation between beta y1 dot 2 hat will be equivalent to the 0 0 format if I use this relation. Like in place of x2i, if I place this lambda into xi, it will be in the indeterminate form 0 by 0. Okay, so in that case, it's very difficult to obtain the value of this beta hat. So variance of sorry, beta 1 hat, variance of beta hat, and variance of beta 3 hat as well, and which will be the function of sigma square and the respective correlation between the two variables. So, and we need to test, and we can do the testing procedure over here as well. So, if you don't want to write this, you can exclude this part and you can directly go for this procedure, where it is going to reflect the variance of the three estimates of the basically the coefficients of the x1, x2, x3, the covariates. And from here you can see that since this, I told you that will be in indeterminate form 0 by 0. So basically this is the problem, that we cannot estimate this particular beta hat, cannot be estimated. So this is the main problem of multicollinearity. Uh, what you have to write, and you can find out the expressions and you can write them. And if you want to include the testing procedure, then you might write that suppose we wanted to test over here that any of the beta i's is equals to 0. Suppose I want to test that whether beta 2 is 0 or not against, so then we have to use the t test, and obviously if it is accepted, we are going to conclude in that way. If it is rejected, we are going to conclude in another way. But for near exact multicollinearity, this kind of situation of this 0 by 0 form does not arises. So we will strict ourselves only to exact multicollinearity only. Is it clear? Is it okay, or shall I repeat anything?
Ma'am, could you please repeat the last part?
Last part, which part? The testing portion?
Uh, from oh no, ma'am, from variance, variance of three constants.
Okay, so you need to find the estimates of these things, and you have to find the variance of these things. If you can recall your concept of linear model, then what was my normal equation? X transpose X into Y curl equals to X transpose beta curl, right? If I am not wrong. Sorry, I am wrong. This. Is it okay?
Yes, madam.
Right? So from here you can find the estimate of beta curl hat, that is the estimate, is equals to X transpose X whole inverse X transpose Y curl, provided that this inverse exists. And if it does not exist, we go for G inverse. Right?
Yes, ma'am.
So what is my beta over here? My beta over here is nothing but, I should consider it over here. My beta over is nothing but beta naught, beta 1, beta 2, and beta 3. Right? So if I can find out this beta hat, so I am actually getting the separate estimates of beta naught, beta 1, beta 2, beta 3. I have not written beta naught because this is not my concern right now. This is only a constant or intercept form. So I am working with beta 1, beta 2, and beta 3 only. So you need to find the estimate as well. And after that, we get the variance covariance matrix, right? Where the diagonals represents the variance and the off diagonal represents the covariance, and it's basically a symmetric matrix. Am I right?
Yes, madam.
Right? So from this variance covariance matrix, you can find the correlation matrix.
Yes, madam.
Okay, so if this variance covariance matrix, these variances are what? This is nothing but if I write x not, if I write something like that, that the constant term, and if I write constant x1, x2, x3, and if I write constant x1, x2, x3, or if I write something say corresponding to beta naught, beta 1, beta 2, so this is nothing but variance between like the two variables. So from this thing you will be getting the variances of the estimates.
Yes,
You need to find the variance of this beta hat. You need to find the variance of the beta hat, which was basically my hat matrix. Can you recall the multivariate regression? Do you know how to find out this variance of this beta hat?
yes, ma'am. Yes, ma'am. By using
Okay.
multivariate analysis.
Yes. What I can do? Okay, I am just sharing another small example with you, which will be a much more easier for you guys. So you can extend it for three variables as well. Okay. Let me consider a small model, a two variate model I'm considering, and I am taking the same thing. Okay, that is this thing. So now, what will be my beta 1 hat if I am not wrong? Let me write this. This is going to be my beta 1 hat. And similarly, you can find beta 2 hat. Obviously, these are least square estimators. Now, see one thing very carefully. If I am writing x2i equals to, what was my x2i? X2i is nothing but x2i. This small x2i is nothing but my capital X2i minus capital X2 bar. I am defining this thing. Actually, I have written in this thing to get rid of the problems. Where I should mention it over here, where yi is equals to capital Yi minus y bar, capital X1i equals to capital X1i minus capital X1 bar, capital X2i is equals to capital X2i, small x2i is equals to capital X2i minus capital X2 bar. Is it okay with respect to the notations? You can check it once. I'm giving you 2 minutes. You can check it once whether you are getting this thing or not. Is it okay? Am I audible?
Yes,
So
ma'am.
in this situation, I have taken x2i is equals to lambda into x1i. If you can remember, since I have taken their correlation to be equal, so that implies that capital X2i minus capital X2 bar is lambda into x1i minus x1 bar. So that is basically this thing. So if we can replace this thing, you will be seeing that this beta 1 hat, which I am giving a notation of like this, is of this 0 0 form. So we cannot estimate this. So hence this is called the problem of multicollinearity. Also you can obtain the variance of beta 2 hat as this. Similarly, when we are discussing three variates model, my variance of beta 3 hat will be sigma square by summation over x3i square 1 minus r13 square. Is it okay or shall I repeat anything? Is it okay or shall I repeat anything?
No, ma'am.
Okay, assuming that it's okay. So I am going for the next question. Since I am discussing this multiple regression, so I am going for the question of heteroskedasticity. Yes. State the methods of detection presence of heteroskedasticity. Discuss any one of them. So, how many methods do you know of detection of heteroskedasticity? Can you explain that how many methods you know of detection of heteroskedasticity? Can you name any of the measures, please?
I'm not able to recall, ma'am. Sorry.
Okay, so can you define the situation that when we say that there is a heteroskedasticity present? Do you know the actual meaning of presence of heteroskedasticity in a very rough sense? Yes. Anyone can tell me the meaning of presence of heteroskedasticity? Suppose for any kind of array type data set, if the variance of this yi is dependent on I. It totally depends on basically this I is not actually sigma square. That is same for all I. Okay. Then we say that the heteroskedasticity is present in my data set. Okay. Then we basically need to test. So what we are testing over here, we are testing that whether these variances are equal not. So we are going for the testing of this thing. For sigma k, assuming that there are k, what there are k y1 y2 yk like the array type data, there are k independent responses are over there. So this is basically what we are testing. We are testing for the homogeneity. Okay. So one of the main testing over here is the Bartlett's test. I told you the name. Can you tell me the detail of the Bartlett's test? Okay, in Bartlett's test, I'm telling you in a brief, the test statistics T is defined as n star log of h square. I'm going to define the symbols minus summation over ni star. Obviously, summation is over I. Ni star log of mine is I square. Okay, first one is s square. The second one is I square. So, what are these things? Where my ni star is my ni minus 1, okay, and my n star is nothing but summation of ni star I running from 1 to k, that is equals to n minus k, okay, where again n is equals to summation of ni. I'm going to tell you where I am from, where I am getting these things. Okay. K is I square is equals to 1 by ni star summation over j running from 1 to ni yij minus yi bar whole square, where yi bar is equals to 1 by ni summation over yij, j running from 1 to ni. And the finally s square is nothing but 1 by summation over ni star I running from 1 to k, summation over I running from 1 to k, ni star si square. So if you can see that, as I was telling about the array type data, so my yij comma xi, this can be one of my array type data where j runs from 1 to ni and I runs from 1 to k. This is suppose one of my array data. Okay, where I am assuming that this yi1, yi2 and yini follows normal distribution with mean mu I and sigma square independently for all I running from 1 to k. Okay. So basically we are testing this thing that whether this sigma i's are equal or not. Hence we are testing for the heteroskedasticity of the data, and this is the scenario that this we are going to obtain. If you can see, this is nothing but the degrees of freedom of the test. So basically t is going to follow nothing but my chi square k minus 1 under the null hypothesis under h naught, and the data is said to be heteroskedastic if capital T is greater than chi square k minus 1 comma alpha. Since we are dealing with a both sided test, so I have taken this as the cutoff point. Okay, this is one of the tests, Bartlett's test. We can go for another test, which is Glaser test. In Glaser's test, what we can do, suppose we are assuming that sigma I square is basically increasing with xij. Okay, that is, it is actually implying that sigma I is increasing with square root of xij. This is what we can say. So we need to first fit a linear model. So first step will be, first fit the linear model by OLS method. And obviously we are going to get some EI, which is going to be the ith residual for I running from 1 to n. After fitting of this OLS method, the linear model, then I am taking this mod of EI is giving me a estimate, rather I should say a rough estimate of this sigma I. So basically this formula says that we are taking this mod of EI equals to delta into square root of xij plus ui, where I runs from 1 to n. This is a model without an intercept, where delta hat is my OLSE, that is ordinary least square estimate of delta. So we need to fit this equation and we need to find the estimate of delta by using ordinary least square. After completion of this process, this is going to be my first step. My next step will be to test H naught whether this delta is equals to 0 or not. Because if my this is the error component, so we are not concerned about this. So if this delta is actually 0, then this relation won't hold. And if delta is not 0, this relation will hold. So basically delta is the main factor over here which we want to test. So based on that, my test statistics T will be delta hat by standard error of delta hat. Since we cannot find the standard error directly, so we are going to estimate them. Since delta itself is unknown and it has a degrees of freedom n minus 1 under h naught. So we can write, so at level alpha, we may conclude that the data is heteroskedastic with respect to xj if my t observed, that is the value of the statistic, is greater than small t n minus 1 comma alpha. Is it okay? And there is another method which is a very big method which I am not discussing over here. I have already discussed two methods. If you want, I can discuss it in the next class, which is Goldfield Quantz test. This is another method. And also for defining heteroskedasticity, can you define, since I have raised this question, so if they ask you that what is heteroskedasticity, so can you just brief out with one or two situations that when or how can we get the presence of heteroskedasticity in a data set? Anyone? Am I audible?
Yes, ma'am.
Yes. Can you tell me? Is it okay whatever I have discussed till far?
Yes, madam.
If you don't have the concept of this testing very clear, so you won't be able to understand this portion. So before you go through this particular portion, you please go through the testing portion once, then you go for this portion. Okay. And can you tell me some situations where you may face the presence of heteroskedasticity? Anyone? Okay, I would like to say that you revise this thing once and then we can discuss this part later as well. Because discussing these things without any concern would not be beneficial, I guess.
Madam, I think it would be good. Sorry, ma'am. Sorry, madam. It would be good if we were informed before what is the topic is going to be discussed.
Okay. Like, no, I actually been informed that we have to discuss the questions randomly. So I am choosing questions randomly. That's why. So regarding that, you can contact sir. Okay.
Okay, madam.
Okay, this is a very easy question which I am discussing today. Explain the time series model and its component. Can you tell me? I hope you will be able to answer. What is a time series model and its components?
Madam, there are three types of models: additive, multiplicative, and uh, mixture of both additive and multiplicative.
And what are the components? So how are you going to start the answer? First think of that and then answer me.
Yes, madam. The components are trend and cyclic variations, uh, and seasonal variations and random. Uh,
No, first, how are you going to start writing? Like basically, see, these are very common question and semester type questions, right? So in ISS, one of the main thing is again is the representation of the thing. So like explain time series model. This is my first part of the question, and next part of the question is to define the components of the model and how it is related with the model. So one thing we can do, we can break up the question. We can write what is my time series model, and then we can discuss its components in 1 and 2 line. Am I right?
yes, madam.
So first we can write a little bit of intro portion, right? And then we can say what are the four components. What will be my four components of time series? One is my trend. Sorry. One is my trend, which is denoted by this. Since all the components are like components are basically with respect to time, so typical time series has these three components. One is trend, next is seasonal, that is my ST. Another one is cyclical, CT, and the third one is irregular. I am explaining this with ITs. In some books, you can get a random component as well. Okay, which is random. So then we can go for the explanation of these things one by one. What is trend? What are the features of the trend? Can you highlight the key points of the trend?
There will be prolonged increase or decrease. Uh, Sorry.
See, this is one of the major components of time series which is always present in any of the time series, irrespective irregular component is there, and in seasonal and cyclical, if there is a presence of seasonal and cyclical component, we need to remove them. But the thing is that this trend is one of the symmetrical component which is very important and which is present always. Okay, so it is basically nothing but like what we called a secular trend. Over a long period of time, a time series is very likely to show a definite tendency. Like if we are measuring data with respect to time, so it will certainly show a tendency. Either it will decrease, either it will increase, like what you were saying, or it will show a fluctuation, randomness. So over a long period of time, it is definitely going to show a tendency, and such tendency may be constant in direction. Okay, may be constant in rate, and not only that, the characteristics of the shift is maybe in the direction or in the rate as well. So maybe in both. Okay, so in that case, this is reflected by this major component of the time series, which is called trend. So in one word, we can say the smooth, regular, and long-term movement of a statistical series is called. So what are the points I am highlighting? Smooth, long-term, smooth, long-term, and next what I said, regular movement of a statistical series. Okay, let me scroll down a little bit. Movement of a statistical series is basically called the trend or the secular trend, with sudden and frequent changes either in the amount or in the rate with respect to the increase or decrease, it quite inconsistent. Like changes in a very short span of time is inconsistent and doesn't match with this word trend. Because if I have a time series data something like this and there is a certain drop, so trend actually we can see this while representing, but it actually doesn't capture this kind of drop. Suppose this is my year data and this is my sales data. Okay, that means over the years, if I say overall the sales is increasing, the sales are increasing. One year, what happened, the sales has dropped, maybe due to some reason, whatever be the reason, that is different concern. But the thing is that it is a smooth long term thing, so it does not reflect, it reflect a constant change in direction, constant change in rate, or constant change in both over the long term, and it is regular and it is smooth with small changes, like frequent and small changes is not captured by this trend. This is one of the main features of the trend. And what are the methods of like this measuring this thing? One is moving average, mathematical curve fitting, and freehand curve fitting. You can just mention them if you wish. Next, we go for the seasonal variation. So what is my seasonal variation? Is the trend portion clear?
Yes, ma'am.
You are not audible. Hello.
Yes, ma'am, it is clear.
Okay, next, seasonal variation. Can you tell me anything about seasonal variation? What do you mean by seasonal variation? So I can say in one word, it is a periodic movement which renews or repeats after some degree of regularity within a definite period. So what are the features or keywords I am using? I am using the keywords, that is, it is a, one second, my graphic tablet is not working. It is a periodic movement, okay, which renews or repeats some degrees of regularity within a definite period, which repeats some degrees of regularity This word is very important because it has a irregularity in it. So we are not capturing the random or irregular portion under seasonal variation. So with regularity, it is with a definite period. Is it okay? But what are the difference between, we can use the almost same features or almost same characteristics is my cyclical variation. Almost same thing. Okay, it's also a periodic movement, and the same point also it repeats or renews with some regularity within a definite period. So can you tell me what is the difference between these two things? Or both the things are giving me the same definition. Both are like incorporating the irregularities, not the regular irregularities, the inherent irregularities, which is basically the randomness of the series that is taken care by the fourth component of time series, but which is like the regularity or some repetitions of the trend. Suppose in every year within a short span of time, I see that in particular this time the cells get increases or decreases. With that kind of thing is captured by this both the things. So what is the difference between this seasonal variation and cyclical variation? In seasonal variation, this periodic movement, the time period is basically is less than 1 year, that is it moves within a year. It occurs, time period is within a year. You can write like this, it is within a year. Okay, where cyclical, it is not within a year, it is of longer duration than a year. This period is of longer duration than a year. Is it okay?
Yes, ma'am.
So you can give a small example. Suppose seasonality means what? Suppose I am tracking the cells of umbrella over a whole year, and I can see during the summer, when the summer is arising, and during the rainy season, the cells of umbrella is a little bit more rather than the throughout the year. There is a cells, but which is moderate or maybe low. But during this particular time, the cells is increasing, and for each and every year, if I break the data monthly wise, then I can see that yes, the data, there is a high cell within the summer months and the rainy season months. So this is considered to be a seasonal variation which occurs within a year. So how can I reflect the cyclical movement? Cyclical movements captures a time period which is more than 1 year. Suppose I wanted to see maybe the cells or something of last 10 years. So within that 10 years, maybe something has happened in the factory, maybe a fire break or something has happened, maybe due to some problem, the factory has shut it down for some few periods of months, and that's why the sales has dropped. Maybe this kind of things has been occurred, and due to that reason the sale maybe has dropped, or maybe due to some reason certainly that products has got high demand. Suppose when the COVID has arrived, the sanitizers, there was a huge demand of sanitizer in the market. Before that, few people are aware and they were using sanitizers, and when COVID has arrived during this March 2020, there was a huge demand of sanitizers. So in that case, the sales automatically increases. So in suppose in future, when a person is going to do the study in suppose say 2025, in the year 2025, taking the data for last 10 years, he or she will see that if the sales of sanitizers has been increased and is increasing for the year, it is almost constant, or maybe there is a little bit of variation till 2019. And when for the year 2020, the sales has increased massively, and till now the sales is in a stable position. Why? Then we need to see the history, and then we will be seeing this. So for any period of depression and prosperity, that is also taken care into account by this cyclical movement. And last but not the least, our last movement, which is our irregular or random component, which is basically, wait, my pen tab is not working then. Yes, the random component, which is nothing but basically the irregular components, which is inherent irregularities present in the time series. Suppose a company, you are seeing a monthly sales of a company or a factory or production of a factory, it is increasing day by day due to some technical error for a month. Maybe the machine has doing some problem, and due to some suppose a company, suppose I am giving an example, suppose the factory has 5 machines, and with respect to that they have started their production, and you are seeing the production of say month of January, month of February, and all the months you are seeing, and the production rate is almost same, and it is quite good. So in a certain month, say in the month of September, suppose 2 out of 5, 2 of the machines are not working properly. So in that month, the company has to rely, or the factory has to rely for the production only on 3 machines. So obviously the production will be low, right? Because within that one span of time, either that company has to manage for another 2 machines, or I have to repair these two, but this needs some time. So suppose that time period is maybe 10 days or 20 days, so that is going to affect the overall production of the factory for the month, or the overall figure, numerical figure of production of that factory corresponding for the month September. Am I right?
Yes.
Suppose you are spending 2 hours every day for preparation for a certain entrance exam, and for a particular month you are, or 15 or 20 days, you have not studied for a single minute throughout the day. So that is going to affect the overall study time. So if I say that how many hours you have studied in this month, so obviously it is going to get decreased. So that means these are working and these are not properly working, is going to affect the sales figure. And from September, from October itself, it is coming back to its own original cells itself. So these are but these machines are not working. Is it in my hand? No, it's not my hand. I need to fix it up, and suddenly there is a, like, a problem has arisen, and which is affecting this thing. These are called irregular or random component, which is beyond my control. Like I have detected this problem, and until and unless I solve this out, I need a time. I need span of time. So this is the irregular component, and when I'm going to plot the graph, it may show you that okay, the cells are increasing. Some for some year it has dropped. For some month basically, it has dropped a little bit. Then it is continuously increasing. So here is that corresponding to this month where there the problem has arisen, but it is so like due to it is very, this is not maybe this much, maybe a very small change, maybe this much, so which is almost like negligible, and this is called the irregular and random component, which is inherent for the occurrence of the time series. So these are the components, and based on these components, what kind of models we have? We have basically, like you said, 3 kinds of model. One is my additive, two is my multiplicative, and three is my mixed type. That is a combination of 1, 2. Okay, and you know that additive model is how to deal with additive model. We all know For multiplicative model, what we can do, the we can take the log, or the natural log base e, that is the natural log logarithm of the model, and then it will become additive. So it's very easy to deal with, because additive models are very easy to deal with. So we can use the same same trick on multiplicative model, and can convert it to additive model as well. And for mixed model, we can use the log trick and can do it, but it's very difficult to deal with. But preferably, we either in real life we use this additive and multiplicative model. We actually don't come across this multiplicative model, because in additive model, my irregular components, it is the basically the range of the irregular components in the multiplicative model is either lies between 0 and 1, and in my additive model, in long run, the sum of the irregular components is basically unity, that is 1. Okay, is it clear?
Yes, ma'am.
Any queries? Hope not. So I am stopping over here.